So today we are going to look at graph, okay? So we are starting with linear graph. Linear graph is a graph of a straight line. So we have a linear graph. So that's what we are starting today with, a linear graph. And I say that linear graph is a graph of a straight line, okay? So that is the graph of a linear equation of two variables, okay? A linear graph is a graph of a straight line. And what is a graph of a straight line? A graph of a straight line is a graph of a linear equation of two variables. We have done linear equation of one variable and we have seen how we can solve that, but we can actually be given a linear equation of two variables and will be asked to represent that equation or represent that problem in a graph. What are we going to do? Let's take example. Let's assume that we are asked to plot the graph of 2x plus 3 equals to y. So we are asked to plot this graph. The question now is that what are we going to do and how are we going to plot a linear graph of this nature, this linear graph of two variables? There are two ways of plotting a straight line graph. But before we continue with that plotting, what are the material that is needed to plot your straight line graph? Of course, you will need your graph, okay? So this is my graph. You will need your graph to plot. Then you will need your pencil. Most times we make use of pencil in plotting graph. Then you will need a straight ruler, okay? Though this one is a short one, so you can get a long ruler, okay? Of course, you might need your pen in case if you need to write. So you will need your pen. Now, let us go get into the business. You have a linear equation of this nature and you are to plot this linear equation. There are two methods of doing that. First thing is that you will need to get the values of your s and its corresponding values of y. You need to get the values of s and its corresponding value of y. So the question now is, how can you do that? So let us tag this one method 1. Let us tag this one method 1. The first method is about creating a table of content for the linear equation. Like I said before, linear equation is the equation that when you plot it on the graph is going to give you a straight graph. Now, how do we create a table of content for the linear equation of 2x plus 3 equal to y? A table of content is a table in a graph. Of course, this two-dimensional graph, two dimension, x and y. X is on the horizontal axis, so we plot our x on the horizontal axis, then we plot our y on the vertical axis. Remember, as you plot it on the horizontal axis, it's being counted vertically. What I mean is that this is the way you count it. Okay, so you count it this way. Now, we need to create a table of content for our equation. What is table of content? Like I said before, table of content is a table that gives you all values of s with the corresponding values of y. So let us create our table. So we can use our ruler here to create a table. Okay, so you can see my table. So you have the up row as your x values and have your y rows as your y values. Okay, so we have created our table. Remember, I have about how many partitions? One, two, three, four, five, six, seven, eight. I do not say that you must make it this long. You can make it two, you can make it three, you can make it four, you can make it five, you can make it six. Okay, so no matter the number of uh, columns or number of partitions you want to create, you will be able to get your straight line because it is a straight line graph. Okay, so for this case, okay, let's reduce this into one, two, three, four. So let me cancel out these ones. Let's see how we are going to get our answer. So I might take it at one, two, three, and four. Like I said, it's a straight line graph. So the numbers that you decide to assign for s, okay, does so long as it's more than two or up to two, it is okay. Okay, so we need to get the corresponding values of y at s equals to 1, at s equals to 2, and s equals to 3, and at s equals to 4. So let us do that working here. So at s equals to 1, we are going to have 2 into 1 plus 3. That will give us our y. Therefore, what we have here is 5 equals to y. That means our y is going to be equal to 5. Okay, so let's come to when s equals to 2. So s equals to 2, we are going to have 2 into 2 plus 3. That will give you our y. So 2 into 2 is 4 plus 3, that will give you 7. So our y equal to 7. Okay, so when s equals to 3, when s equals to 3, that will give you that 2 into 3 plus 3, that will give you our y. Then 2 times 3 is 6, 6 plus 3 is 9. So our y is what? 9. And when s equals to 4, you can have 2 into 4 plus 3 equals to our y. Then our y is 8 plus 3, which is 11. So we have 11 here. Like I said before, it does not matter if you have up to 3, 4, 5, 6, 7, or more than that, the number of value of s. So long as you have up to 2, okay, 2 is enough to give us our straight line. 2 is enough to give us our straight line, but you can create your table to have up to 4 numbers, 1, 2, 3, 4. You can create to have up to 5, 1, 2, 3, 4, 5, at uh, uh, as much as you can. Okay, so but I always advise for you to just pick few numbers, 3 or 4 or 5 number maximum, to be able to get, so that you can be able to finish up fast. Remember, time is a factor in mathematics. Okay, so with this now, I will now go to my, I will ask myself, which scale can I use? I have up 5 to 11 on the y-axis. So I will come to my graph. Okay, I'll come to my graph. I need to know the scale that I will use to be able to get up to 9 numbers. Remember, we have 9 here, we have 9, we have 11. So which partition are we going to use? If we use each of these, if we use each of these as 2 or as 1, are we going to get up to 11? That's a question we need to ask ourselves. And it's not good that we pick a number that cannot be able to exhaust all the numbers you have in your table of contents. Okay, so we have to look for a way to choose a scale. Now, what we mean by a scale? Each of these, each of these is being measured from here. Each of these big balls, okay, this box, each of these is measured as 2 cm. Okay, so we need to know what this 2 cm will represent, and we also need to know the value of the tiny lines on the graph. Okay, so from here to here is assumed to be 2 cm. So from here to here is 2 cm. So if we take it as 2 cm to represent 1 unit, can we be able to get up to 11? So let us check that. So we have, if you take here as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, but it will make our graph to be so down. Okay, so we can take it as 2, 4, 6, 8. We can take it as 2, 4, 6, 8. Okay, 2, 4, 6, 8 definitely give us more than 11, and our line is likely to come down here so that we can get up to 11. Then on on S axis, we don't have problem on S axis. We can see 1, 2, 3, 4. So we are going to take it as 1, 2, 3, 4. So I will go to my graph now and rule my line. So since I don't have any negative value of S, so I can just rule my line at the middle, or I will shift it towards the X axis. Okay, I believe you can see the pencil. So I have my line. Let me bring my X axis a little bit down. Now, after ruling this line on this graph, I need to identify the axis. So here is X axis. Here is my X axis. Okay. And this side is my minus X axis. Then up here is my plus Y axis. Then down here is my minus Y axis. Okay, so with that now, I can have here as 1, here as 2, here as 3, here as 4, here as 5, here as 6. I can have here as my 2, that's 2, 4, 6, 8, 10, 12, 14. Then here is the middle of the graph, which is definitely our 0. So down here is negative Y axis, so minus 2, minus 4, minus 6, minus 8. So here is negative X axis, which is minus 2, minus 4, minus 6. Okay, so with this now, I have finished labeling my graph. So the next thing now is to plot my values. Okay, when X is equals to 1, Y equals to 5. Now, like I said before, we need to know the value of each of these tiny lines. How do we know the value of each tiny lines? Now, let us write our scale, the scale we are using for this graph. So if you look at our x-axis, we pick each of these 2 cm from here to here, which is 2 cm. We pick it as 1. Then from here, another 2 cm, another 1, which make this one 2, plus 1, 3, plus 1, 4. So each 2 cm here is represented as 1. So we say 2 cm, so this is our scale. 2 cm represents 1 unit on x-axis. Then when you come to the y-axis, you can see that from 0, the next 2 cm is 2, the next 2 cm is 4, the next 2 cm is 6. So we can say that 2 cm represents 2 units on y-axis. Okay, so this is our scale for that graph. Now, after this scaling, the next thing to do is that we need to know the value of each of these tiny lines we are seeing. These tiny lines, we have 10 lines. There is 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 lines. Okay, so we need to know the value of each one. Now, on x-axis, so for the tiny lines, so I can write it for the tiny lines x-axis. How will I know the value of each of these tiny lines? It's very simple. What is our 2 cm representing? 2 cm is representing 1 unit on x-axis. Therefore, each tiny line on x-axis will give us 1/10, which is 0.1. Then on y-axis, you can see that we have from here to here is 10, is 2. So, and we have 10 lines, so it's going to give us 2/10, which is 0.2. So each tiny line on the x-axis is 0.1, while each tiny lines on the y-axis is 0.2. So this is how to get that. Just find out the unit that the 2 cm is representing and divide it by 10, because there are 10 lines. Okay, so let us come now and locate our points. Okay, so when s equals to 1, y equals to 5. So here is 1, so we need to get to 5. Here is 4. Okay, here is 4, so I will count. Remember, each of the tiny lines is equals to 0.2. Okay, so I will now count 4, 4.2, 4.4, 4.6, 4.85. So this 5 is at 1. Okay, so here and here is the point that have 1 on x-axis and 5 on y-axis. Okay, so the next one is 2 and 7. So I will do the same thing. Here is 6, so this 2 and 6 here, so 6.2, 6.4, 6.6, 6.8, and 7. So you can see that even two line can give us our straight line. With this point and this point, I can use my ruler and get my point. But let's first finish locating all the points. At 3, 3 and 9, so here is 8. Then you now move 3 point and 8.2, 8.4, 8.6, 8.8, 9. So here is our 9. Then for 4 and 11, so 4, you now move to, there is 10, so 4 and 10 here. So we need to get to 11. So that will give us 10.2, 10.4, 10.6, 10.8, 11. So put our points. Now we have gotten all the points in the table of value. Okay, in the table of value, we have gotten all the points in the table of value. So the next thing now is to plot the lines. Okay, so I will use my straight ruler. Though this my ruler is short, you can use a very long one to plot your graph. Okay, so I'm going to manage this particular ruler. Okay, make sure that you don't just place your ruler and draw. You place your ruler, use your pencil to be sure that your ruler is actually at the point, so that when you rule your line, it will not be off the point. So I think I have gotten it. So I can narrow my line. So I can even extend my line. I can extend my line to go down the graph. Okay, so it's always nice when you are done with your line, you write the equation that gave you that line. So I have 2s plus 3 equals to y. So this is my graph of this equation. So I hope you have seen the way we plotted that graph. Okay, so this is my graph of this equation. Like I said, there are two methods of plotting your graph. Okay, there are two methods of plotting your graph. I'm going to show you the second method using the same equation. I'm going to show you the second method using the same equation. So I plotted my linear graph. So I'm going to show you how to plot the graph, another method on how to plot the graph. So our second method, let's call it method 2, okay, is a very simple method, okay. So I'm going to show you this method so that you can be able to make your choice on whichever method that you decide to plot or decide to use to plot your graph. Now, this second method is very simple also, okay. What is this method? This method is, we already have our equation. So let's write out our equation, which is 2s plus 3 equals to y. Now, I have my equation here. What do I need in this second method? In this second method, I'm going to look for the value of x when y equals to 0, and also look for the value of y when s is equals to 0. So what does that mean? It simply means that if I come to this equation here, when y equal to 0, I need to find the value of my x. And when s equals to 0, I need to find the value of my what? Of my y. Okay? So let us do that. It just requires a little working. So let's work that out. When y equal to 0, so let's find the corresponding value of s when y equal to 0. That will give us 2s plus 3 equals to 0 because y is equal to 0. So that will give us 2s equals to minus 3. Okay, when you divide both sides by 2, you have 2s over 2 equals to minus 3 over 2. So 2 will cancel 2 here. I have s equals to minus 1.5. So when y equal to 0, when y equal to 0, I have s as minus 1.5. Okay, so we are going to still do the same thing for when s equals to 0. When s equals to 0, so that will give us when s equals to 0. So I will put my s as 0. So 2 into 0 plus 3 equals to y. So this one will go, anything multiplied by 0 will go. So I have 3, therefore y is equals to what? 3. So here is 3. Okay, so I will now go to my graph. So we are going to plot another graph. This is the previous one. So let us open our graph. So we are going to use this. I have explained about uh, scaling before, so I don't need to explain that again. So I will rule my line. Okay, so this will give me 1 here, 2 here, 3 here, 4 here. The good thing about this one is that I don't need to write too much numbers, okay? Because all I need is just these 2 points, okay? These 2 points. When s equals to 1.5, y equals to 0, and when y equals to 3, s equals to 0. So that's the only thing that I need. So I have 1, 2, 3. I won't be needing much here. So I have -1, -2, -3. I will need this minus because I have s as -1.5. So I have 2, -2, -3, -4. So remember to put your y here, and you have your -y here, and you have your x here, and you have your minus x here. Okay, now how do we make use of this? How do we make use of this to plot this graph? When y equal to 0 is on this axis, when y equals to 0 is on this axis, okay, on s axis is where y equals to 0. Now what happens there is that at y equals to 0, at y equals to 0, s equals to -1.5. So I will go to my x and get my -1.5. That's -1. Remember, we shown how to get the value of your tiny lines. Okay, so on s axis, based on the the scale that we are picking, s axis each tiny line is 0.1, while y axis each tiny line is 0.2. Okay, so I have my -1, so -1.1, -1.2, -1.3, -1.4, and -1.5. Remember, it is on the x-axis, on the x-axis, because y equal to 0. Now, when s equals to 0 will be on the y-axis. Okay, when s equals to 0, y equals to 3. So we have 1 here, we have 2 here, we have 3 here. Okay, now there's something I have noticed in our graph which is not right. We numbered the positive y-axis as 0, as 1, 2, 3, 4, and on the negative part we used -2, -3, -4. So that's a little mistake we have there. So let's wipe it off. They have to be uniform. If you are taking 1, 2, 3, 4 on the positive side, you're also going to take -1, -2, -3 on the negative side. But I want us to have it with the same numbering that we have in the other graph. So this will give us 2, 4, 6. That's what we have. 2 here, 4 here, 6 here, 8 here. So here is going to give us -2, -4, -6, -8. Okay, so when y equal to 0, s equals to what? 1.5. We have gotten that point. Then the next one here is when s equal to 0. Okay, when s equals to 0, y is equals to 3. So we have 2 here, so we need to count 3. Remember, the tiny lines on the y-axis is 0.2. I have shown you how to calculate that. Okay, the unit that each 2 cm is representing, you divide it by 10, so that will give you 0.2 on the y-axis. So here is 2, here is 2.2, here is 2.4, here is 2.6, here is 2.8, here is 3. So with these just 2 points, we can draw our line. We can get our straight line graph. So all I need to do is to place my ruler in order to get these 2 points in a straight line. Okay, so with that now, I can now draw my line. Remember, you can extend your line. If you are using a long ruler, this should be easier. Okay, so you can see my straight line. So like I said before, it's always good to write your equation on the line So you can see what we have now. Okay, so I'm going to show you the two graphs so that you can see it very well and see that they are actually the same using the two methods. Okay, okay, so this is the one that we use so many points. Okay, this is the one that we use this one for. Okay, so you can see it. This is the one we use these points for, so you can see it. So this for method one. Okay, which you construct a table of values. So you now make use of your table of values to locate the points and join the points with a straight line. Then this one is the one that we use the second method for, which we just need only 2 points. When s equals to 0 and when y equals to 0, the corresponding value of y and s. So this is our method 2 graph. This is the method 2 graph. Okay, so whichever one that you prefer, it is okay so long as it's a straight line. You can actually use these two methods to solve. Okay, so in our next class on graph, we are going to look at simultaneous equation graphical method.